Hi friends, good morning. I am here with another problem on strain energy. So let us start with numerical number 3. A cantilever beam of uniform cross section carries a point load at the free end. Determine the strain energy in the beam and deflection at the free end. Provided P is equal to 200 kilonewton, E is equal to 2 into 10 raised to 5 MPa, L is given as 3 meter, and moment of inertia is given as 10 raised to minus 4 meter raised to 4. So let us begin with the solution. It is relatively an easier problem. So what he is trying to tell here is he is having a cantilever beam which is subjected to point load. So first let me draw a cantilever beam. Right. So now you just draw a cantilever beam. Length is given to me, so need not worry about the length. Okay, so this cantilever beam total length is given as 3 meters. So L is equal to 3 meters. At the free end, it is subjected to a load of 200 kilonewton. Okay, so here it is P is equal to 200 kilonewton. Okay, now before I could start with the core part of the problem, so I'll be writing an expression for strain energy stored in a beam due to bending. Strain energy stored in the beam due to bending. So that is U is equal to integral of m square dx divided by 2 into EI. It is for the entire length 0 to L. So this all of us are aware of. Now here I want to find out m square. Now in order to do that, what I'll be doing is I'll be taking a section at certain distance from the right end. So let us say I'll be taking one section here. Right, so this is section YY, and this distance from the extreme right end is X. So here M, how you are going to calculate M? In order to calculate M, I'll be making use of this. So consider a section YY, consider a section YY at a distance X from free end. So therefore bending moment at the section YY will be equal to My, and I'll take it as M because I want to substitute it here. So that will be equal to how much? It will be equal to minus P into X. Why minus P into X? A reason is simple. P is acting downward, X is the perpendicular distance, so P into X we got to know. Now why this minus sign is coming into picture? Because in case of cantilever beam, will be moving from right to left. Will be moving from right to left. So when you are moving from right to left in this direction, the clockwise movement caused will be taken as negative. So here there is a clockwise movement with respect to section YY, so that is the reason you are getting this negative sign. Right, so therefore equation 1 becomes, therefore equation 1 becomes, so you substitute U is equal to integral of 0 to L. What is the value of M? M value is minus P into X. We need to square that into dx divided by 2 times E into I. So that will be equal to, constants please keep it out, P square divided by 2 times EI Getting integral of 0 to L, this will be x square into dx, right? Now therefore u is equal to p square divided by 2 times e into I. Now this will be x cube divided by 3, and it will be from 0 to L. So therefore u is equal to, what we'll be getting here, p square. Now this becomes L cube divided by 3 to the 6 ei. We will be getting this value. So this is the expression for strain energy in case of a cantilever beam subjected to point load at its extreme free end. Now you are knowing the value of P, you are knowing the value of L, you are knowing the value of I, you are knowing the value of E, so you can easily calculate the value of U. You directly substitute things and you calculate. So let me go ahead and substitute the values given to me in the problem. So we know that U is equal to P square L cube divided by 6 EI. I have just derived this. So I'll be substituting the values. So I am in need of U. Value of P given to me in the problem is how much? 200 kilonewton. So I'll just put it in Newton. So 200 into 10 raised to 3. Value of L given to me in the problem is 3 meters. So it is 3 cube divided by 6. Value of E given to me in the problem is how much? 200 GPa is 200. Value of E given to me is 200 into 10 raised to 5 MPa. So how we can write this? So value of E given to me is 200 into 10 raised to 9, that is GPa. Now it will be Newton per meter square, into value of I given to me is 10 raised to minus 4. So therefore value of U will be equal to, so let me check out. So it is 200 into 10 raised to 3 into 3 3 is 9, 3 is 27 divided by 6 into 200 into 10 raised to 9 into 10 raised to minus 4. So I have gone wrong during the calculations. Once again let me check it. It is 200 into 10 raised to 3, 10 raised to 3 into 3 cube, that is 27, divided by 6 into 200 into 10 raised to 9 into 10 raised to minus 4. So I am getting the value as, okay, after simplification I am getting the value as 9000. Getting the value as 9000. Unit will be Newton meter. Newton meter. Now what mistake I had committed is I need to take it as a square. It is P square. I had taken it as P. So don't make such silly mistakes. That is the reason I was getting some wrong answer. 0.045 is a very less value. I got to know that it is wrong. So once again when I just checked it, I got to know that I have not squared this. Right. So this is how you should be able to judge your correctness of the problem on the answers what you get. So it is 9000 Newton meter, or you can also call it as, or U is equal to 9 kilonewton meter. Both are same. Okay, that was the first point what he has asked. Next he has also asked you to calculate the maximum deflection. So maximum deflection in case of a cantilever beam. So if I just call it as, some people call it as Y max, some people call it as delta, both are same. I told you it is a standard result and you need to remember this, that is PL cube divided by 3EI. Okay, so this is a standard result, so you need to remember this. Value of P is once again known. Value of P is 200 kilonewton, so it is 200 into 10 raised to 3. EL is again 3 cube divided by 3. Value of E is once again 200 into 10 raised to 9, and value of I is 10 raised to minus 4. Right, so let me calculate. 200 into 10 raised to 3 into 27 divided by 3 into 200 into 10 raised to 9 into 10 raised to minus 4. So it is 0.09. So therefore y max is equal to delta is equal to 0.09, and it is in meters. So how you convert it into mm? You multiply it by 1000. So it will be r y max is equal to delta is equal to 90 mm. Right, so that is your answer for maximum deflection. Now one thing you might have noted, that in the given problem E is given in MPa. E is given in MPa, that is 2 into 10 raised to 5. E is equal to 2 into 10 raised to 5 MPa. So that is 2 into 10 raised to 5. M is megapascal, so mega is 10 raised to 6 and it is pascals. So it is 2 into 10 raised to 11 pascals. So this I can write it as 200 into 10 raised to 9 pascals. So that is 200 into 10 raised to 9. Pascal is Newton per meter square. So therefore E is equal to 200, 10 raised to 9 is giga, and Newton per meter square is once again pascals or Newton per meter square. So that is how you can write it as 200 GPa, and 200 GPa is 200 into 10 raised to 9 Newton per meter square. I was substituting everything in Newton and meters. That is the reason E, which was given to me as 2 into 10 raised to 5 MPa, I have substituted it as 200 into 10 raised to 9 Newton per meter square. Only then I'll be getting the answers in correct units. Right, so that's it for today's session. Have a great day. Take care. Bye bye.